So what are the common processing we could do on two-dimensional arrays? We will go into this one by one. First, how to initialize arrays with input values. Input values, it means how to take the data from the user and save them into the two-dimensional array. The best way to do it is to process the array row by row. So you create a nested loop. The outer loop is responsible for counting how many rows, and the inner loop responsible for counting how many columns. You display a message to the user to enter the data row by row. You display a message enter, and you display the number of rows, and also you display how many columns. And the user input the data row by row. As you notice in the inner loop, we are referring to the index row, which is the outer loop, and we are referring to the index variable column for the inner loop. And as you can see that every number we read from the user is saved into this index variable that is referenced by row and column. Printing arrays. Again, for printing arrays, we should not print them column by column, because this is how it is saved inside the two-dimensional arrays, that we save the data row by row. As we mentioned, that two-dimensional arrays were arrays of one-dimensional arrays. So again, to print the data of a two-dimensional array, you need to process the array row by row. Like initializing arrays, printing arrays are the same. So inside the inner loop, you print the variable, index variable, that is referenced by row and column. And see that the row index variable is the variable for the outer loop. And the outer loop is responsible for number of rows, and the inner loop is responsible for number of columns. Next, how to find the summation of all elements. And here it doesn't matter if you process the array row by row or column by column. So you have a variable that will have the total for all elements, and then you process the array by using two nested loops, and inside the inner loop you write total plus equal the index variable matrix row and column. And notice that for the first variable index, it is row, it is used for the outer loop, and the outer loop is responsible for number of rows, so that means the processing will be row by row. Now what if we want to find and print the summation of each row? Then for each row, that means you have to process the array row by row. So the outer loop is for the number of rows, and the inner loop is for number of columns. But notice that we have a total variable that is not only initialized before we enter the outer loop. We initialize it inside each iteration of the outer loop, and the outer loop is for number of rows. So that means if we are in row 0, we initialize total to 0, and then we consider this row as a one-dimensional array. We go over the elements one by one, and we find the total. After we finish, we print a message saying that sum for row 0 is equal to the answer. In the next iteration, for the next row, we have to initialize the variable to 0 to find the summation of the new row. If you don't initialize it, then you will have the same situation for summing all elements, and total will be used for finding the summation of all integers in the array. What if we want to find the sum and print it for each column? Then you don't have to do anything other than make the processing column by column. So make the outer loop responsible for counting number of columns, and the inner loop make it responsible for counting number of rows. And don't forget that in each iteration for a column, you need to initialize total to 0, so that once you find a total for one column, for the next column you have to initialize this variable to 0 to find its total. Next, common array processing for two-dimensional arrays is how to find the maximum value. For finding the maximum value, it doesn't matter if you process the array row by row or column by column. And here in this listing, we are processing the array row by row, because the outer loop is counting the number of rows, and the inner loop is counting the number of columns. So how to find the maximum number in the whole array? You assign a variable, you call it max. Here we are assuming that the array is of type integer, and you make it equal to the first entry that is in the first row in the first column. And then you process the array elements one by one, testing these elements with this maximum. If it is greater than the maximum, simply replace this index variable with the maximum. After you finish, then you print that the maximum is equal to this variable, which is equal to max. Just remember, how did we find the maximum in a one-dimensional array? That we assign the first element in the array as the maximum. And then we test every element in the array one by one against this variable. If it is greater than this variable, then we replace it by this index variable. If the whole numbers inside the array are positive and guaranteed are positive, then you can start maximum equal to -1. So the first element that we will see inside the array will be tested against this maximum, and it will be greater than, and it's going to replace it. So therefore, if we are not guaranteed that the entries inside the array are not all positive, so the best way is to assign the first element in the array as the maximum. Now, what if we want to find the maximum in each row? Then you need to process the array row by row. And again, you need a variable that will hold the maximum for each row. If we assume that we are processing a two-dimensional array of type integer, you make it equal to 0. But this is only for not making the compiler complain that maximum was not initialized, because this variable will be changed in each row. Because each row is a one-dimensional array, like what we have done for finding the maximum on a one-dimensional array, you assume that the first element in the array is the maximum. So if we are processing, let's say, row 0, then you assume that the first element in row 0 is the maximum. And then you start from column 1. So notice here, we are not starting from column 0, we are starting from column 1, which is the next element in this row. And then you test it against the maximum. If it is greater than the maximum, simply you replace it. After we finish from the inner loop, which is finding the maximum for that row, we print the maximum for this row, and then in the next iteration, it's going to find the maximum of the next row. So this is why we need to process the array row by row. And don't forget that for each iteration of the outer loop, you have to assign the maximum, the first element in this row. Otherwise, it's going to find the maximum number in the whole array. And again, if you want to find the maximum in each column, all what you have to do is that change the processing from row by row to column by column. So you make the outer loop responsible for number of columns and the inner loop responsible for number of rows. In this way, you are going to visit the array column by column. In each column, you will find the maximum and print it on the screen. Notice that the printing is happening after exiting the inner loop. So the inner loop will find the maximum, and then when you exit the inner loop, you print the maximum for that column. Also, as a common processing for two-dimensional arrays, it is requested to find the average value in the whole array. Then here again, it doesn't matter if you process the array row by row or column by column, as long as you are going to visit every value in the array. In this listing, we are visiting the array row by row. So what you do to find the average, you need a variable for holding the sum, and after you find the sum, you divide by the number of entries in the two-dimensional array. So after you find the summation of all entries inside the two-dimensional arrays. When we say entries, it means the values inside the two-dimensional array. And if we want to talk in terms of arrays, it is the indexed variables by the row and column. After you finish and exit from the two-nested loop, then you divide the summation of all numbers divided by the size of the two-dimensional array. And the size is found by multiplying number of rows by number of columns. Similar to finding the sum and maximum value in each row, the question is how to find the average of each row too. To find the average of each row, you need to process the array row by row. You make the outer loop responsible for counting the number of rows and use its variable, I mean the for loop variable, as the index for the first dimension of the two-dimensional array. And make the inner loop responsible for counting number of columns. Use its variable, I mean the for loop variable column, as the second dimension of the two-dimensional array. In each iteration of the outer loop, you are visiting a row. You find the average of this row and print it. So after you exit the inner loop, you print the average. But don't forget that to initialize the variable sum in each iteration of the outer loop. In other words, in each row, initialize sum to 0. After you find the sum of all elements in this row, then you divide the summation by the number of columns or by the number of elements of this row. which is matrix row dot length. This is if you want to find the average of each row. If you want to find the average of each column, simply you process the array column by column. So you don't change anything in this code except you make the outer loop responsible for counting the number of columns, and the inner loop make it responsible for counting the number of rows. And this way we'll find the average for each column.